from that to pull-ups, and then straight from that to taking dumbbells, jumping up and down like 100 times. You're gonna die. Literally.
Look, I wrote -1 on there.
All this is cookies.
And then I think it's that they tell teachers.
All right, how about this? I didn't hear this. They're gonna eventually open it to the public. It's just not there yet. But like right now, any student or staff member at any of the schools can use it. Why isn't this working?
I don't know.
It's not even. Here's what I like about graphing sine and cosine. If you pick these 5 points, the shape is always the same, just the labeling changes. So that's why I say it's really important to label your axis, because the shape is going to be exactly the same. It's going to go down here, then it's going to go down to -1, back to 0, back to 1. And it's going to be that lovely little wavy W that it always is. But what's important, if I was grading this, I would be looking to see if it is labeled correctly, if you picked those 5 points. If you didn't pick these 5 points, you end up having to pick a lot more points to get that full period, and you end up maybe not getting very nice points. So that's why this is a good strategy to do. But big idea from yesterday, amplitude, period, vertical shifts maybe. Okay, so let's finish this up. Wrap up this graphing stuff.
Oh shoot. It's really bad.
I really gotta get this started.
Those TVs that they got in the weight room, they're 2 decent sized TVs.
You don't need to talk to me about this, kids.
They're like the size of my TV in my house, and like I don't think.
I'm just saying that could go to something better for the schools. I mean, honestly, that money could go to something better.
Like the 4 baseball fields.
Like a better smart board.
You guys, why do you guys talk to me about this? It is not my decision about any of this.
Because you actually listen.
The only other teacher I have is Dobson. Like, do you even read Dobson about?
Yes, I do. We decided last hour someone needs to perform a switcheroo with Miss Dobson's smartboard for my red ink, my red pen for her red pen. So one of you in Miss Dobson's English class got to take on the challenge of switching out the red pens.
I will be. She's not even in there until like they're about.
But you got to check and make sure they're the same. They got to be an even trade. You think she'll know this?
Does she even use it?
She doesn't use it.
Does Mrs. McNabb use it? I should just go ask them if I could trade them.
What's so different about
Yeah, I could do that.
She uses it so much that it's like,
This is what it's supposed to look like, and this is what it looks like since I use the red one all the time. And maybe I write really hard.
I go down there. I just walk inside of it. I don't even say a thing. I just go and then walk out.
Yeah, I'm really thinking that like.
like as they're just like, what are you doing?
I'm just like switching on and working like.
Just don't even look at it.
Don't even play. Yeah, just head down. Just like.
Well, I was supposed to dance this and that, but in there, so I just.
I'm not gonna steal it. It's just I'm just teasing.
That's not stealing. That's replacing.
Yesterday we talked about this form of the equation, and we're going to kind of summarize all this again, but we kind of skipped over this C, if something's added or subtracted inside the function. Normally, like on a normal graph, we just say that shifts it to the left and to the right. It's what this one does too, but it's just a little bit tricky to talk about how much is it switching. So if we solved this for x, if we talked about normally sine makes one complete cycle from 0 to 2 pi. So if I set this equal to 0 and I set this equal to 2 pi, I just want to kind of show you where this formula comes from. Not that you really need to know this. But if I solve this for x, do you agree that I would just add c over? Then I would divide by b, and I would get x equals c over b. And if I did that for here, if I added c to 2 pi, I can't add c to 2 pi. I would just have to write that as c plus 2 pi. and then I divide it by b. I'm going to divide everything by b like this. I would get x equals c over b plus 2 pi over b. So this kind of proves where both our formulas come from. What's this 2 pi over b represent? Our period. So if your period changes, then this changes, right? If b is something, then that changes our period. But this c over b represents how much it's shifting to the left and the right. So that's really what you need to know from this section. What does c mean? Well, how much it shifts to the left or the right is always c over b. And instead of calling it a horizontal shift, for some reason with trig we call stuff different, right? We call a vertical stretch the amplitude. We call a horizontal shift the phase shift. We say the phase shift is whatever c over b is. And so again, you're not going to have to graph any of these with the phase shift because they're a little bit trickier to graph. I'm going to show you some in a minute, but you're not going to have to graph them on your homework or on the test. But I just want you to know that if you see something added, that it's going to shift your graph, which means things can look a little tricky. Actually, sine functions can start to look like cosine functions and the other way around. So on the next slide here, I just kind of went back to that whole thing. This is what you need to know from this section on your test. All right? For graphing, if you see sine or cosine, you need to know what all of these letters represent. All right? So what is the amplitude of something written like this in sine or cosine? What is the amplitude, formula-wise? The absolute value of A, the number in front of sine or cosine. So if they ask you for the amplitude, it's the absolute value of the number multiplied in front of sine or cosine. If nothing's there, that means the amplitude's 1. It's not stretched any. The period is what? 2 pi over b. So the number in front represents your amplitude. The number in front of x represents your period. And remember, if that is 1, the period's just 2 pi. The new part is shifting left and right is your phase shift. So it's kind of hard to see all this, but you need to know this. Maybe we should just write phase shift here. Can I write phase shift? So this is c over b. So it's not just c. If I ask you for the phase shift, you have to remember that it's c over b. And what did we say d was? A vertical shift up or down. So d is a vertical shift. There is for sure a question on your test that they give you a function, either sine or cosine, and they ask you all of those things. What is the period? What is the amplitude? What is the phase shift? What is the vertical shift? And so you got to know what all those numbers represent. So let's do one. Putting all this together. On your test, you're going to have a question like this. And it's going to say, find the amplitude, the period, the phase shift, and the vertical translation. Meaning all those things. So let's just write that out. I think on your test it even writes it out like that. Amplitude equals period equals. So this is if you get it right or wrong. There's sound effects. All of the sound effects. Phase shift. Vertical shift. So what can you answer right away? Do you know what the amplitude of this is? See, look, I'm recording now and it's working fine. So there's no point in me ever asking for them to fix it because why does it work sometimes and not other times? The amplitude is the absolute value of this, which is just 1/2. Oh, look. I said that and it stopped working. 1. Dang it.
Just go in, don't even look at it. Don't even look at anybody.
Yes, you have to do it. Super short operation. No. You wouldn't know.
Period is 2 pi over b. What is b in this?
Pi x measure.
Nope. B is
Oh,
just
okay.
pi, which means the period of this is just 2, right? The pi's cancel out. We're going to graph one like that in a second. That's what we did yesterday. The phase shift is the new part. The phase shift is C over B. Be really careful, though, that when we wrote that out, we always wrote BX minus C. So C is really +1, not -1. You see that? Because the formula is BX minus C. So if it was a +1, then you take the negative. So the phase shift should be 1 over pi. This would be really ugly to graph. I might graph it on the graphing calculator in a minute just to show you what it looks like. But that means it's going to take your graph and shift it 1 over pi units, which means your x-axis is going to be really weirdly labeled, right? Really weirdly labeled, which is why I don't make you graph them. And what about the vertical shift in this? Vertical shift is like the d value. Is there anything added or subtracted outside of here? Which means there's not any vertical shift. So you can say none or you can say 0. It's the same answer. There we go. Good job. Randy? Doesn't work for me anymore. Oh. Was it snowing here last night when you went to bed? Nothing. Nothing. I don't know. Think about it. Okay. Let's go see like a block. Let's graph one more of these just because we haven't graphed a negative and we haven't graphed one when the period doesn't have pi in it. And there's going to be a couple on your homework you have to graph today again just for some good practice. But the majority of your homework is just listing what we just did. Period, amplitude, vertical shift, phase shift. So what is the amplitude of this? The amplitude is still just 1. What does this negative in front mean is happening to my graph? It's going to be the opposite. So normally it starts up at 1. It's now going to start down at -1. So everything we get normally we're going to change the sign of. And my period is going to be just like on the last one, 2 pi over b. Oh no, it's actually going to be different. It's going to just be 1. Do you agree with that? Because 2 pi over 2 pi would give me a period of 1. So when I pick my points, 0 to 1, what do I do to get the ones in between that? Take half of it. So what's half of 1? A half. What's half of a half? And what would be halfway between a half and 1? Which is always going to be these two added together. Right? So think about, we kind of just took the pi out of it. Think about those pi fourths, pi halves, 3 pi fourths, 1. Because there's a pi up there. There's no pi in it. So now be careful with plugging these in. You can always just plug them in. This will be on the calculator portion of something. So if you forget what the values are, you can always plug it in. But when you plug in 0 here, cosine of 0 is 1, but the negative in front make it -1. When you plug in 1/4, you should get pi halves up there, and you do. And the cosine of pi halves is 0, -0 is still 0. And this one normally is -1. I think it should switch to +1 because we get pi, cosine of pi is -1, but negative of a -1. But again, you can just type that in your calculator. This one should go back to 0 because it should give me 3 pi halves. This one should end back up at 2 pi, but that negative out front makes it negative. So you got to remember the negative flips it over. So when I make my points here, again, I don't need to make past 1 and -1, but I got to remember it's flipped over. So it's going to start down here first, then go up to 0, then go up to 1, then go back to 0, then go back to 1. And it's the same on the other side. where knowing that original graph is very helpful. You will not have to graph any with a phase shift, okay? So that's kind of a nice thing. So I have another thing that's not on your slide, but just to kind of show you this little interactive thing so you can see what happens as A, B, and C change in your graphs. Oh, look at this. So this is a sine function, and I can switch to the cosine function in a minute. But notice A is the number in front. So right now A is 4, right? Normally we think of A as 1 because that's a normal sine function. But think about what happens as you make A bigger and smaller. Then the negative flips it over. Let me go back to like 5 there so you can see. B is your period. So notice as I change the period, the larger that I make that number, the smaller the period is. So the more squished together it gets until eventually it just, ooh, that's crazy. I wish you could do like fractions on this because that makes it better, but it doesn't. Like, they don't give you fraction options, so you can't see that it stretches out the period. And C is the part I really wanted to show you. C is the phase shift, which means as you change C, notice that it kind of just slides that graph down. So do you agree that if you had the right phase shift, that your sine graph could look like your cosine graph? Because you could slide that down enough that it would cross at 1 up there, right? If I could change that to 1. So that's something I like to remind you of. And I can do the same thing for cosine. Like I could switch cosine and I could slide it. Oh, don't let me go anymore. I can just slide it down. So all C is doing is shifting where that graph starts. It's the same shape, but it's just shifting it, so it's a lot harder to graph it by hand, which is where calculators come in handy. Okay? Make it look like a heartbeat. That'd be a crazy one to graph. All right, so, ooh, it's like doing the wave. Sorry. Kind of a cool thing. Here's your homework, mean homework. Bishop say 9 through 27 multiples of 3. That's an important part. Make sure you listen about this. The directions, you are not going to follow the directions because on 9 through 27 multiples of 3, it says find the amplitude, the period, and the phase shift, which I want you to do. But it says to sketch each of these graphs. But the only two I want you to sketch are 21 and 24. So on all the rest of them, 9, 12, 18, and 27, you're just going to say the amplitude, the period, the phase shift, and maybe if there's a vertical shift, you should say that too to practice doing that. But you don't have to graph any but 21 and 24, which are ones that don't have phase shifts on them. Okay? And if you have graph, you probably have graphing from yesterday. Maybe that you could still use. But if you need more graph paper, I'm just going to stop this.